happened to the volume? Decrease as we expected. So if you change this to temperature over here because you made a mistake in algebra, so you know that you did wrong because you know that it's supposed to decrease the volume. Okay? Yeah, of course I have before. So, and now we're going to talk about Gay-Lussac. Gay-Lussac was the scientist that studied the pressure and temperature. So the effect of the pressure and the temperature and the pressure. So he says that pressure is directly proportional to temperature. That means when you see in the graphic, look what happened when I increase the pressure, when I increase the temperature. If I increase the temperature, the pressure increase as well. So if I increase the temperature, I increase the pressure. And we remember that, right? Remember, because when we increase the pressure, the temperature, we increase the movement of the particles. If you increase the movement of the particles, the molecule will hit the wall constantly, more constantly, like more times, several times. So the volume, the pressure inside will increase. Okay, so we are keeping the volume constant over here. The volume is constant. That means I have a container that cannot increase volume or decrease, so that is constant. So when I increase the temperature, the pressure inside of my container will increase because the particle is getting crazy, moving like crazy. Okay, so and we have the formula of the Gay-Lussac that says that the pressure and temperature are directly proportional, and this will be constant. That means if I increase the pressure, I will increase the temperature. If I decrease the pressure, I will decrease the temperature. So the value will be always constant over here. Okay? And this is what I was talking about. So I have a steel cylinder over here. So when you see an increase in the temperature, the pressure here, look at this, I double the temperature, I double as well the pressure. And this is a kind of container that cannot increase the volume, so I keep the volume constant over here. So, and that makes sense because if you want to study the impact of the temperature and the pressure, I need to keep the volume constant, otherwise I will not see the pressure because the volume will increase, so the pressure will be constant. Okay. So how are we going to apply? The same thing, you need some algebra if you want to organize your formula to find the variables. And let's go to example over here. A steel container of nitrous oxide at 10.4 atmosphere is cooled from 33 degrees Celsius to negative 28 degrees Celsius. What is the final volume and the constant volume? Actually, the question here is the pressure. What is the final pressure at the constant volume? I'm sorry, this is wrong. Okay, for any gas, law calculations involve temperature. We must convert the temperature and Celsius. Remember that. So I have the temperature 1, and I have a temperature 2, and I have a pressure 1. So if you have a pressure and temperature, we know that we are studying Gay-Lussac problem. Okay, so we have the formula because we know that P1 T1 is equal P2 T2. So if you want to know this, I'm going to multiply both sides by T2. So I cut off this, and they're going to have P2 over here. Okay? So now it's just plugging your data as soon as you convert the units, and you're going to have your pressure over here. What happened with the pressure when I decrease the temperature? Decrease as well. So I start with 10.4 and now I have 8.33. Remember, pressure is directly proportional to the temperature. That's Gay-Lussac. Okay? So if you know the concept, you know how to evaluate yourself, you know if your problem is right or wrong. Okay? Let's do one more. I have 25 milliliters sample of neon gas at 455 millimeters mercury is cooled from 100 degrees Celsius to 10 degrees Celsius. If the volume remains constant, what is the final pressure? So I have volume 1, which is 25 milliliters, and he says that they will keep it constant, so I don't need to worry about that. Okay, so my volume is constant, so it's not volume 1, it's volume. So I will not need that because I'm studying the pressure, the effect of the pressure. So I have the pressure 1, 455 millimeters mercury, and I have the temperature 1, so 100 degrees Celsius. So plus 273, I have 373 kelvins, and I have a temperature 2, and I have 10 degrees Celsius plus 273 will be 283 kelvins, right? And now I have pressure 2. So I know P1 T1 equal P2 T2, right? And I know that if I want this, P2 will be P1 times T2 divided by T1. So what I'm expecting here, the temperature decreases, so that means the pressure will decrease. Okay, so pressure 2 will be P1, 455 millimeters mercury, times T2, 283, divided by 373. So now my P2 will be 405 times 283 equal divide by 373. Oh, sorry, 373. So will be 345 millimeters mercury. What happened to my pressure? My pressure decreased. So, and this is right because I know that Gay-Lussac says the pressure is constant, is proportional, is directly proportional to the temperature. So if I increase the temperature, I increase the pressure. If I decrease the temperature, I decrease the pressure. Okay? And then we have the combined gas law. So the combined gas law put all the three laws